Hello everybody, my name is Tony Morbin and I'm the Editor-in-Chief of SC Magazine. Welcome to our webinar 2015, the Year of Securing Big Data and Cloud Environments. For analysts, the more data they have, the better they're able to spot patterns, and the more robust their conclusions as well. But for those tasked with ensuring information security, the more data that's held in one place or accessed by one person, the less secure it becomes. Then, when we throw in the mix the use of cloud services, where data is effectively stored on somebody else's computer, the lack of control makes many organizations anxious. But there are solutions to overcome this apparent loss of control and to secure this data that resides beyond the perimeter. And chief among them is the use of encryption, as we'll discover in today's webinar. Our speaker today is Sol Cates, the Chief Security Officer at Vormetric. As CSO, he's tasked with ensuring Vormetric's internal security profile remains robust, while keeping his finger on the pulse of developments in technical and business decision-making processes for today's IT/IS organizations. Cates partners with teams throughout the company and the industry to engage with both customers and partners. He also promotes industry understanding of data security best practices in today's complex cyber threat landscape. Today, Sol will discuss how we secure information in the era of big data and cloud environments. We'll have Q&As following Sol's presentation, so you're welcome to ask questions via the interface at any time. Welcome, Sol. We're pleased to have you with us.
Thank you very much, Tony. I really appreciate the time today. So as Tony said, I definitely want to focus a lot on the big data and cloud environments that most of the participants today are probably embracing or their organizations are embracing, and really focus on what some of the challenges are, not only from a data governance and security perspective, but also just adoption. You know, there's been many different starts and stops of initiatives that I've seen throughout many organizations where they want to embrace these technologies, yet they find quite a few deal breakers in their investigations into embracing these technologies, and talk about some of the challenges and how you can overcome them a bit today. So a quick agenda, what's sort of driving the adoption of big data and in cloud, what some of those data security challenges that we hinted at earlier, really what the big needs are in big data. If you look at big data, it's not just a big database, it's a different type of architecture depending on the platforms you've chosen to embrace, and they have many different touch points, whether it's the consumption of data, the production of data, or even the analysis of data. It's in a new environment and a new architecture, and the traditional controls that people are used to using to actually help protect and safeguard that information don't apply necessarily. So there's new approaches you need to look at, and really talk about having your data in somebody else's house. How do you protect that? When you start looking at cloud service providers, whether it be a SaaS provider, infrastructure as a service provider, even PaaS or platform as a service, all these different architectures and capabilities that they bring to the table, they have a different set of controls for your information. You're going to be housing your information in their architecture, and what some of the challenges are, as well as what some of the approaches are that customers and prospects that we've engaged with have been successful at throughout the industry. And then we'll talk a little bit about Vormetric from the approach and what we do from a technology standpoint, but also really share some of the stories we've helped our customers become successful at embracing these technologies. And then finally, we'll follow it up with Q&A. So, very little secret. If you actually look inside of any architecture, so for the last 30 years, we've really introduced a new concept called the privileged user or the super user inside of our architectures, whether it be a database, application, an operating system, what have you. When we left the mainframe, we introduced this concept of what we call ring zero. And our system administrators, network administrators, database administrators, they all leverage that level of privilege throughout their architectures to actually perform the functions they need, such as I need to change a configuration, I need to install a patch, rev a system. But with that comes all the access to the data. And what we've seen over the years, as we've seen in our Insider Threat Report, is the privileged user is the number one risk to information inside of a traditional IT organization. If you start looking at other architectures like big data and cloud, when you start embracing those technologies, now you have a third leg to the stool where there's now that privileged user inside somebody else's organization potentially. that would have access to your information? And what are some of the things you can do to help mitigate or reduce that risk? So as you know, data is increasingly more difficult to protect. As most organizations, including my own, we embrace many different technologies, whether it's your traditional 3-tier applications you might host either on-prem, in the cloud, or even in a traditional ISP or MSP. But you also have other technology you're embracing that are more utilitarian, such as your infrastructure as a service and software as a service providers, where you're going to embrace their go-to-market strategy for how do they actually service you with a value add. The problem is, though, is data is data. At the end of the day, data is ones and zeros, bits and bytes, has no built-in defense of its own. So it always depends where you put that information, where is it housed, where is it used, where is it produced and consumed. That location is very key because when it's in that environment, it's at the mercy of the controls and safeguards that are in that particular architecture environment. So, for example, in the physical data center, we have a lot of perimeter controls, even internal controls that a lot of the organizations embrace to help reduce or mitigate the risk of that information inside the data center. But once you start bringing in third parties, such as a cloud service provider, or maybe embracing, an Amazon use case for big data, for example, how do I actually make sure that the data that goes into those environments is secure? It's very challenging because you don't own the infrastructure anymore. You don't own the administration underneath the hood. At the end of the day, that data center is somebody else's. That's a different house. How do you protect that? And the challenge is not just so much that there's more and more vectors to the data, but there's also just more data in general. I think what we've seen from a lot of our organizations is they are wrestling with how much data they produce and collect, but also how to classify it. Classification of data is not a new topic. It's been around for quite a bit. And folks are still trying to wrestle with how to simplify the classification, but also make it consumable to the business. And we start talking about the volumes of information they've created here in, not only on-prem, but also in cloud and big data platforms. That amount of data, but also the variety of it is can be very struggling or very hard for an organization to embrace and figure out how to actually protect it inside those different environments. And as you know, big data is definitely a newer technology that a lot of organizations want to be able to leverage to either find new markets, find new services they can provide back to their customers, detect fraud easier. I mean, there's a lot of different use cases for it. But the challenge is it's not like a traditional database where you have, controls that you're used to, whether it be database activity monitoring, even, column level encryption, even database encryption. It doesn't apply the same. The controls aren't the same. The ACLs aren't necessarily the same. And a lot of these newer technologies don't have security bolted in at the beginning. They're sort of afterthoughts that a lot of organizations wrestle with. How do I add encryption or add access controls or add appropriate security controls onto the data repository when it's a newer architecture? And so it really heightens the need to protect that information because what I've seen from a use case perspective, a lot of organizations wrestle with the concept of the data that's going to go into a big data repository doesn't necessarily fit a standard schema, right? So classification of it can be very challenging. For example, let's say that I'm a bank and I've got a potential use case where I want to look at transactions of my customers to find out how can I service them better. The challenge is that the information I might be putting in there could be from many different sources. And based upon that source, the classification, governance, and risk of that data being, and the sensitivity of that data is variable. Right? I don't know what it is at any given time. We've seen this over and over again with customers within the industry, which is the company wants to embrace these big data platforms. I don't know what's going to land in this repository. I don't know if it's PCI data, PII, or PHI until it happens. So it's a reactionary type initiative. They have to figure out how to wrestle or lock down or keep that data out of that environment from at the very beginning. So it's definitely heightened the awareness because these repositories become very valuable. It's not just the the individual pieces of the data that are valuable. It's also now the aggregate. As you actually start creating or doing analysis on your data inside these big data platforms, the value you get out of it is very high. But with that, it's also very high to other adversaries, whether it be external hackers, it could be state-sponsored, it could even be industrial espionage, where the results of that are very, very valuable because you're going to make a business decision or a mission decision based upon the output of that. So it's very, very critical that you make sure that not just the data that's going in it, it's not the data just in the big data platform, but also the results you get out of it. What are you doing to make sure that they are appropriately handled, controlled, and managed? And as we all know, data has no built-in defense. I think it's one thing that over and over and over again we talk about, how do we protect information? We just have to really, understand that data has no built-in defense. There's nothing about a document that makes that document protected. There's nothing about a record in a database that protects it. The data itself has no built-in defense. You have to bring defenses to it. Things like encryption and access controls are always going to be dependent upon where you're putting this information, and how I can invoke those controls. So they are very good controls to make sure that your information is only used by those that are authorized. However, you have to make sure that it's consumable back to the business as well. And there's really no built-in defense of data. And as we hinted at earlier, big data does not necessarily equal security. One of the things that we've seen is a lot of these platforms, these big data platforms that have come to market, a lot of them started as open source projects. And as is commonplace, a lot of the open source projects start off with features and functionality, unless they are security focused. They start off with features and functionality, and then later on, the enterprise, as they start to try to adopt the technology, push back either on the open source community or or they'll embrace the open source community to help enable the security features they need, or they'll look for the go-to-market partners that emerge from those open source projects to actually put the onus on them for making sure there's appropriate security controls inside these platforms. Quite often they rely upon simple things like file permissions. Hadoop, for example, in its first iterations were really all about making sure that the data was available, it was replicated, it was consumable, and it was easy to actually create MapReduce functions or MapReduce jobs and get the results you wanted. To protect the information, it really relied upon basic ACL, or access controls inside of the application. It had nothing to do with the infrastructure. Anybody in the infrastructure could still get to the information, so it didn't have security built in from day one. And we've seen this with other architectures over and over again. And a lot of it's really focused around identity and identity and authentication, where in reality you also have to bring in that third piece of the puzzle, which is authorization. Are you authorized to see this information? And it's not just the data scientists you're trying to control and make sure they're authorized. It's everybody else too. One of the things we've seen over and over again is the adversary wants to become you. And so one of the best defenses and strategies that we've seen for our customers is once you identify the sensitive information and where it's going to reside, you need to figure out how can you protect yourself from yourself. Your IT administration, your privileged users, could be data scientists, could be end users, but you need to make sure that you have appropriate controls in place to make sure it's the least privileged. Only those that need to see the information are able to do so. And in big data platforms, it's not built in. You have to bring techniques or technologies or push on the vendors to actually help bring those capabilities into the platform. So if we look at the top 10 security challenges for big data in cloud environments, this is actually from the Cloud Security Alliance. They did a survey about a year ago. I think these are the top 10 that popped out. And really when people look to actually embrace these technologies, a lot of the controls or the challenges they saw are not new. These are sort of, traditional concerns you have inside of a traditional database or a traditional application stack. But that said, a lot of it is we just don't have the expertise in big data that we do in other traditional or legacy application stacks. So things like, granular audits or data governance, and looking at things like endpoint input validation and filtration. I mean, we have a lot of different controls, whether it be web application firewalls, you have things like database activity monitoring and so forth in your traditional environment. They don't necessarily apply here in the big data in cloud environments. And so what we've seen from a best practices for actually how do you secure big data in cloud environments, it should really be able to provide protection for the data repository and all data that resides in it. At the end of the day, and I've heard this actually multiple times, there was a credit card company, I won't name who they are, but they actually had mentioned that they really didn't know what data would reside inside their big data platform. at any given moment. So they had to take a high watermark and say, at the minimum, we'll put these controls in because based upon the type of data that we know potentially could land here, here's how that data is regulated, here's the appropriate controls for it, or the required controls for it. We're going to make that our baseline for the entire repository, regardless if it's HR data, PCI data, or PII data, or PHI. Data is data to them, and it saw that the repository had to have some minimum controls. So things like, encryption of sensitive data, DLP, data loss prevention, making sure it was looking outside or taking the data outside of the repository. Really look at real-time data activity monitoring. So who's interacting with the data? How is the data coming into the repository? Is it coming in from databases? Is it coming from flat files? Making sure you're understanding exactly what's coming in and how it's going out. And then who is interacting with the information. Quite often the who is a process, it's an application, but at the end of the day, there's an end user somewhere that's going to consume that data. It's making sure the path to that data is very, very well controlled. So as we see, as people start embracing big data and cloud, actually even in just traditional database architectures as well, is the adoption of encryption is definitely, ramping up. I think, if you look 13, 14 years ago, when Metrics first started, we were an encryption company, and we're a data security company now. When we first started out as just an encryption company, there really wasn't a market for it. No one was really embracing encryption outside of a couple pockets of specialized interest where they wanted to protect sensitive information. It wasn't until the advent of things like compliance. PCI is a good use case where there was a prescribed control that everyone shall have this base minimum in place. And that helped to drive the adoption of encryption for quite a while, but it was very specialized. But now we're starting to see this ramp up within the industry where more and more companies and organizations want to actually embrace encryption simply because of the fact it's a very well-known control to invoke least privilege. You have to have the key to see the information. You have to decrypt the information and use it. The challenge has always been, how do I balance that? How do I make it usable, consumable by the business, yet find a way to actually control access to the data, the key, and all the headache that goes with traditional encryption and key management. And so what we're starting to see is as people find that there are simpler ways to deal with this problem, and they're starting to embrace companies like Webmetric to actually help simplify the adoption of encryption. They're seeing a lot of benefit because, A, they're able to help meet their compliance requirements. They're also able to reduce their risk to data because you're forcing only those that need to see the information through the front door, through the right application, can ever actually consume the data, yet still make it operationally feasible, not only from operations, the day-to-day management of the platform, but also not impact performance so bad that it actually brings the organization to its knees. So there's been a lot of success with that over the last couple of years, simply because of the fact it's getting easier for people to actually embrace encryption and whether it be application-level encryption, file-level encryption, volume-level encryption, network encryption. There's many different types of encryption of data. But when we start talking about data at rest, which is what the majority of all data breaches are about, is they are stealing information from a repository somewhere. It's making sure that that can't happen and help reduce that risk wherever possible. It's a great control for that. So we're seeing a wider adoption. One of the things that sort of highlight is, as you start looking at these big data platforms, whether it, again, be Hadoop, it could be Couchbase, it could be Mongo, DataStax, there's many different vendors out there and architectures. But at the end of the day, they can consume all sorts of type of data. A lot of them are schema-less or no SQL. And with that, it means that the data inside there, it could be any form, any variety, and lots of volume. That's part of the big data idea, is you want to have a lot of variety, volume, and velocity of information coming in and out and making decisions. But based upon that, the inputs of that data could be sensitive. It could be regulated. For example, if I'm a government agency and I want to look at how do I find out, maybe I'm in the census, and I want to actually look and look at the census to find out how many of a certain demographic I have in a certain region. All the bits of information I need to bring in based upon where they came from could be regulated. It could be sensitive information. It's PII. That could be bringing in things like PHI if I want to look at the health aspects of the population in certain segments. So big data is a great platform for doing that, but the sources of that data could be sensitive and regulated. And when you start talking about the distribution of how big data works, it could be spread all over the world. Your big data repository doesn't have to sit in one data center in one country. It could be spread in multiple places. So how do you wrestle with things like data governance and data across borders initiatives, particularly in the EU? And that's where we're seeing a lot of adoption of things like encryption and access controls to make sure the data doesn't cross boundaries where needed, or only appropriate usage of that data is allowed for the business functions that need to see it, and only those individuals that are authorized to do it or see that information are allowed to. So Formetric actually has been around for a while, and one of the things that we've brought to market a couple of years ago is really to help our customers understand the different types of ways you can actually encrypt and protect data. So you have, your traditional, databases and application servers and so forth that actually produce and show information, but they could potentially be repositories of information you want to bring into big data. So what we've seen is customers have different approaches. You could either encrypt the data from day one before you even created it, say it's a sensitive thing like a social security number or a tax ID number. That number needs to be protected. Maybe you encrypted it at the very beginning when you first created the record inside your application. Application encryption is a great technique for that. But you must understand that throughout its life cycle of that data, now every time I need to actually look up that information and use it from a business perspective or an application perspective, I need to be able to decrypt it and utilize it. So you have to make sure that there's a balance there, understanding, yes, I can create it and secure it at its, at creation, but throughout its whole life cycle, I have to make sure I have at every step along the way the ability to decrypt it where needed, be able to actually utilize it. And that's one approach, and that's a very common approach, is encrypt the data at source or at creation, as long as you can consume it in the back end still. And there are certain types of data that maybe don't need to be encrypted. So we see a lot of customers talk about encrypting everything, and that's not necessarily always the wisest choice. It's really, you need to focus on the sensitive stuff and making sure you can put the control in there and its life cycle. There's also transparent encryption. So this is, again, another thing that we commonly see is where people transparently encrypt data. And we do this through a technology called Formetric Transparent Encryption. And its capability is really to wrap around the data in whatever environment it's in, whether it be big data, it could be up in Amazon Cloud, it could be in Azure, it could be in your data center, in Turkey. At the end of the day, it doesn't really matter where the location is. And what it does is it encrypts the data, and through policy says which processes, users, applications, and so forth can decrypt the data, and we will encrypt and decrypt on their behalf. This is commonly used in traditional legacy databases, but now is also heavily used in big data platforms, simply because of the fact of I don't know what data might end up in these data nodes that are spread across the architecture. I need to make sure that I can protect and lock down that data in that repository and only allow the big data platform to consume and utilize that data. And quite often what we've seen is the big data repository, the actual data nodes, might not even be in your own infrastructure. It might be a third party. A lot of customers are leveraging cloud for big data, at least in their initial steps into it, simply because of the fact it's much easier to bring up a bunch of nodes uniformly in a, for example, an infrastructure service provider like Amazon. I can bring up a big data platform, test it, play with it, and then shut it back down. Again, the data inside that area or inside that repository is going to be stored on their infrastructure. Is that infrastructure exposed to your information? Yes. Can you find ways to control it? Yes. One of the ways to do that, encrypt the data. Only allow your business process and application to consume and utilize that data. But then the third part we talked about earlier, which was the output. Right? Now I've actually put all that data in, ran it through my big data repository, made some interesting analysis, and what comes out of that is the result sets. That data, those reports, whatever the case may be, wherever it's going, it's potentially now even more sensitive than the components that made it up. It's the aggregate. It could be very, very sensitive. So making sure that that is also protected is very key. So things like, again, application encryption or transparent encryption are good techniques to make sure that the data at rest in those locations is only accessible by the business processes or the business users that need to do it, as well as making sure that we audit all that activity. Who's touching this information for what reason? And this is where we found a very good solution for our customers that no matter where the data resides, if it's at the source, if it's in the data repository, the big data platform, or the output of that, throughout its life cycle, the data is protected and monitored and controlled. And what's sort of interesting is as people start to embrace more and more cloud architectures, again, whether they be software as a service or infrastructure as a service, we're starting to see a lot more adoption of cloud services. But one of the things that always holds folks up is how do I actually protect the information? Because I don't own that infrastructure. If Amazon does not, is providing me a base service, and I can utilize those services, but the onus is on me for all data security. It's actually in their contract. And it's pretty common across a lot of organizations or a lot of service providers, is they put the control and requirements back on the customer to make sure any data encryption or data access or data protection, it's their responsibility, particularly in infrastructure as a service. Software as a service, organizations like yourself actually have, some leeway here. You can have a lot of pressure to make sure that your service providers are providing the appropriate controls or allowing you to bring your own controls. That, BYOE is something that we're seeing more and more of, where people want to bring their own encryption. They want to enable encryption inside the cloud, whether it, again, be Amazon, it could be Rackspace, it could be, at Task, it could be a lot of different, types of architectures. But the customer wants to hold the keys. They want to be able to control access to the information, control access to the key, and also remove themselves and their data from the environment at the drop of a hat. Be able to actually redact the information very, very quickly. One of the best ways is actually to take the key away from the environment. You have to manage the key for that. So this is what we've partnered with a lot of service providers. So everybody from Rackspace to Firehose to even Pegasystems and essentially Savvis. A lot of these technologies, even Google cloud platform, they all have partnered with Vormetric because their customers are asking for how can I allow them to utilize my platform yet not but allow them still to keep the keys on-premise and control access to the data on-premise. And this is where we've had a lot of success because our customers, are utilizing these service providers. These service providers are part of our cloud security program to really help them, enable their customers to adopt their platform. And as big data, again, is being widely adopted, again, Vormetric has partnered with all these. You look at whether it be SAP HANA or Mongo, even DataStax, we are the chosen vendor for data encryption and security for these organizations because they're not in the encryption business. They're not in the security business. They're in the big data business. We help them answer the question to the customers, how do I protect my information, protect my data inside these data repositories that I'm creating, and what's the best practices. And they're partnering with Vormetric because we bring a very good control. We make sure that the only way that the data is ever consumed is through the appropriate applications that will consume data inside that big data or produce data in that big data environment. The actual infrastructure itself should never be exposed to the data, whether it's on-premise or in the cloud. Your big data repository should not be storing the data in the clear because anybody on the platform can come and look right at it. And when you start looking at third parties to host your information, all the disks, the OSs, and the network layer, all throughout that, it's all in the clear without someone in control like encryption. So here's a good simple use case, and this is something that we did a couple of years ago. It was one of our first big data use cases about 5 years ago, I guess it is now, when it was still coming on board and people were starting to get familiar with the big data architectures out there. And really what they had as a challenge is they had multiple different data owners. So they had I won't say what the organization was, but their use case was they need to take data from multiple different sources and run analytics on it, and based upon that, we're going to perform some action. The source data is very, very sensitive. It's actually regulated by the government. It has different level of security clearances based upon who you are. And those different data owners are responsible for that data set. That data cannot merge together. Traditionally, user 1 and user 2, they can't share each other's information because they're completely siloed. However, to be able to actually utilize that and make some interesting decisions based upon potential threat, they need to be able to bring that information into a repository and make sure that it can be consumed and some kind of action can take place later. What they found and how we helped them is we encrypted each of the data owners' data, and we allowed them through policy to say when they're ready, they can elect to actually submit their data to the big data platform. When it goes there, it stays encrypted. So data from the 3 different owners will be brought into the big data platform, each with their own unique key. So the data is encrypted with their own key. And the big data platform is only allowed to decrypt it through the applications that are allowed. So, for example, if I want to take data from owner 1 and owner 2, mix them to find some kind of interesting patterns, I have to decrypt both of them. The platform is the only thing that's allowed to actually decrypt that data. The underlying infrastructure, the applications above it, are not allowed to do so. Only the job is allowed to. And this allowed them to meet the security requirements and meet their burden of proof for their auditors to show that the data, while it was being mixed, was still never consumed by human eyes. It was only the platform itself can actually decrypt the data for the analytics for that short period of time, and then the results set that was sent out is again encrypted and protected with another set of keys to make sure that only the analyst that needs to see the data at the very end is able to do so. So the entire life cycle of the data can be protected throughout the architecture. This was on Hadoop at first, and then it morphed into many other different architectures throughout our other customers where they need the sort of same concept. I need to have data that might have different security requirements or regulatory requirements based upon what type of data it is, and I bring it into a platform like Hadoop or Mongo or what have you for analytics. When I bring it in there, I need to make sure it's protected and only usable by the business process or the mission process. So what we're seeing, and this is where we partnered a lot with companies like Intel and MongoDB, for example, where we want to find fast performance with encryption. So what we found is when we went from V2 to V3 of the newer architectures from Intel and Mongo, when we brought it into the architecture and actually ran the without encryption and with encryption, the actual delta was fairly minimal. Actually, at first we were about on par, but when we did some optimizations, we actually found that we could actually make it faster than the baseline. And the reason for it is because we put a lot of optimizations into how data flows and how data is stored, accessed, and computed. And with that, and leveraging Intel's newer AES&I instruction set for the cryptography itself, we're actually able to increase the I/O performance in some cases. So we actually had some benchmarks that we run that are MongoDB's benchmarks. We ran through them with and without encryption inside the labs, and actually got back results that were increased in performance, which is not atypical for Vormetric. We've been in the data optimization data optimization business just because of where we sit inside the organization. We touch all your data. We're encrypting your data. We've got to make sure it's readily available very quickly. So we've optimized how data paths work, and we get some advantages of that. So while I'd never say buy Vormetric to get better performance, it sometimes is a benefit that we see just because of how we optimize how things behave inside of operating systems. And as you start moving towards big data, and again, this is why Vormetric partners with companies like SAP HANA, we're just finishing up the certifications there. VirtuStream is been a partner of ours for well over a year now, maybe 2, where we are the chosen encryption vendor for those platforms because people want to bring in SAP to into the cloud, right? Traditional SAP infrastructure inside the IT data center is very expensive, very time-consuming, and so forth. They're starting to leverage partners like VirtuStream and big, SAP HANA Cloud. Those, newer architectures or newer platforms again require data governance and data protection. So where they sit is now going to be in the cloud. Where that data sits is now in the cloud. How do I protect that? This is why these companies have partnered with us, because they know their customers want that level of protection, and we allow them to do so while the customer can still keep the keys on premise. So there's a lot of future relationships with these companies. It's definitely growing and growing in popularity because customers want to be able to embrace the cloud. They like the idea of SAP HANA. I mean, it's a very, very, very robust platform. But as people start moving towards the cloud, they also have to meet that same basic requirement of how do I protect the data and who owns the keys and who can see my data. Once it's outside of my house, how do I protect that? And lastly, I'll leave it with the Vormetric platform architecture. So Vormetric actually provides a lot of capabilities. We have a couple key components that we focus on. So we have what we call our data security manager. It is the brains of the architecture. It's where all the keys and policies and so forth are managed. But then we have other applications that hang off of that. We have our transparent encryption. We have application encryption. We have key management. We actually are, I think this morning, announcing our tokenization product. So what's sort of interesting is we have a lot of different types of tools that actually hang off of our data security manager to provide different levels of protection regarding where your data sits. 90% of the time, people go with the transparent encryption just because it's highly performant. It doesn't change anything that I'm doing. I don't have to change my architecture. And I'll work with almost any kind of database or application or big data platform, and almost any service provider too. Or you go the application encryption route or tokenization. We have tokenization with dynamic data masking coming out as well. So what's sort of interesting is we give you a platform and a menu to actually be successful within the organization. And no one wakes up in the morning and says, I want to encrypt my data because it's a good idea. I've never seen that happen. But after 1,500 customers and a little over 10 years now in the industry, what I've found is when people are forced to encrypt data or protect information, they want to usually do it the most efficient way. They don't want a very big, I don't want a bunch of point solutions that have a lot of management and SME expertise that must be kept on staff. So they want a simple platform that gives them options. I want it to be able to transparently encrypt. If I have to go application encryption, I can do that. Maybe I want to tokenize some of the data as I'm bringing it into a big data platform, for example. You need different techniques or different approaches to the data, again, based upon where it is, what environment it's in, because data has no built-in defense. So we give you the menu of how do you want to protect your information. And we'd be happy to chat with you about it at some point. And with that, Tony, I'm going to pass it back over to you for the Q&A.
Excellent. Well, thank you very much, Sol, for a very interesting presentation. I'm sure you've already addressed a lot of the concerns that people have, but we will now take a few questions from our audience. Now, one of the first questions that people are asking, what are the drivers behind securing data held in the cloud and within big data environments? I mean, is it purely compliance and fear of penalties, reputational loss, financial loss, or just harnessing a more efficient approach?
Yeah, I guess if you look at what are the driving forces, there's usually tactical driving forces, and there's more strategic ones. So when I say tactical, I mean it's usually reactionary. So for example, as I'm embracing a cloud service provider, a big data provider, and I'm going to be hosting PII or PCI type data, I know the controls that must be present there. So things like encryption are very, very important to me there. So quite often it could be very, very reactionary to compliance requirements. As I'm embracing a new platform, I've got to make sure it fits in the framework of all the regulations that I will be subject to, and now my third party is now subject to as well. And so this is where a lot of organizations spend a lot of time on vendor negotiation and vendor management, making sure the vendor itself is actually putting the right controls in place. And that's one thing that I always encourage a lot of organizations to look at is when you're doing your vendor selection for a new platform, a cloud, big data, what have you, a lot of these companies, these Tier 2 and Tier 3 companies, I would say are not very robust. They're servicing the enterprise in some cases, but they're not an enterprise company themselves. So they don't necessarily have all the traditional controls and processes you would want to see as a large organization. So it's one thing, word of caution is always when you're looking at these service providers and what you're going to use them for, do you take the risk on of them managing your data? That's essentially what they're doing. They're going to be managing your data. Do they know how to do so? And do they do it sanely? Also, do you have appropriate controls to influence their management of your data? So again, things like encryption, access controls, auditing capabilities, do you get that level of visibility into how your data is behaving in their platform? That's what I always ask you to look at.
I was going to say, so that sort of slightly preempts one of the questions that was coming up, which is looking at how to minimize the risk. When you're looking at providers, is there a checklist that you should be asking your provider during your due diligence, or is it really down to ensuring that your contract terms and conditions cover every eventuality?
Yeah, I think, that latter one you just talked about, the CYA contract negotiation, as I always like to call it. When you're going through that, you're trying to make sure that the third party or the vendor has the appropriate controls. And, it's hard to verify. That's one thing that's really challenging when you're talking with a service provider. They have many customers. So, you have to be a fairly large customer to get them to play well from a negotiation standpoint. But also, the other challenge you have is when you're doing that vendor selection and you're doing that contract negotiation, where's the risk to the data? Every time I look at a contract from a service provider, there's always a clause that says that the data security of the information in their repository or their platform is my responsibility. As soon as I see that, I start asking a series of questions. All right, how do I control? I need to understand the hows. How do I control access to data? How is the data accessed? Who has access to the data inside your environment? And when I start going through those series of questions, if I don't get solid answers back, it becomes a high risk. If they come back and they have, blank stares or during the headlights looks, at that point, I think there's might be a lot of risk to that particular organization. I mean, one good checklist to go and look at is the Cloud Security Alliance. They actually have a great program, the STAR program, that actually lists all of the service providers and how they've actually attested either self-assessment or third-party assessment based upon their ranking system of how secure are they, what controls they have in place, and are they able to demonstrate it. And I highly recommend people take a look at it because the CSA does do a very good job of verification across multiple customers, as well as working directly with the service provider. So it's a good checklist as well. So if the vendor that the organization is looking to embrace is not in the top of that list or don't have good rankings, I would definitely take some caution and look at the risk that they might pose to your information. And also look at what kind of data you're putting up there. I mean, there's some organizations that think everything that goes into the cloud must be protected, and there's some data that's just not valuable to anybody. I always say, what is the crown jewels? Are you putting your crown jewels in the cloud? If you are, you need to be very clear.
You're getting on to the next question, but just while we were on responsibility, though, what I was going to ask, we've got a question here. Again, it's largely the area you were covering, but you're saying that particularly if you have multiple service providers, you have one person providing the big data hosting, you've got somebody else potentially providing encryption. What are the legal implications if there was something, if the worst was to happen, both in relation to me and my customer, but also me and my service supplier? Who does take responsibility when something goes wrong? And I'll just carry on slightly on that. What happens to my data if my outsourced provider goes bust?
Yeah, it's always a very good question. Yes, again, when you're going through that vendor selection, right, I mean, the responsibility of who owns the data, but also the data control and the data availability, those are always questions that I want to make sure I understand when I'm looking through a vendor. The reason is does the vendor have the ability to recover themselves? Do I have the ability to recover myself, right, as well as who has access and who has control of information? So we start talking about encryption, for example, and who has the liability of the keys. The keys themselves are the keys of the kingdom, right? If I don't have that key, I can't use the information. Who has access to them? Where are they stored? And how are they, how are they highly available? So if my service provider went bust, they had an outage, they, got acquired, or they just ran out of business. Do you have a backup strategy? It's just like anything else. If you're going to go into a new data center, for example, what's your backup strategy? Same concept. How do you actually back out of the service provider? And I think that's one that I found that some service providers, especially the lower tier ones, they don't really have a good answer of how do I get my data out of your environment. And it's not that I don't trust them. It's that I need to have the ability to recover myself operationally because I'm putting a lot of eggs in a basket. If that basket's got a lot of holes in it or it decides to go up in flames, I need to have the ability to go and put my eggs in a new basket or recreate my eggs somewhere else.
Absolutely. Now, you touched on the crown jewels, and actually again, you started to answer what I was going to ask, which was a lot of companies do take the crown jewels approach and put their most critical information separate from the rest. Does that mean that they can't really take advantage of these sort of big data services in the cloud where you're combining big data, both your crown jewels and your less precious data, to be able to draw conclusions?
Yes, you can, right? And this is where, I highly recommend to customers that are approaching this, this conjunction where I've got different data sources, right? And one of them might be very, very sensitive. But because it's so sensitive, I need to make sure it's protected, but it also might be very, very high value to me. I need that extra little bit of the data mixed in there to be able to find, another piece of the puzzle that I'm trying to research in my analysis. If you want to combine that with other things, you have to look at techniques like either application encryption or tokenization. Those are really the only, that and even transparent encryption will work in some states. It just really depends on where the data is going to reside. So if you're going to look at a big data platform provider and that sensitive data is needed in there, does it need to stay in that state for the analytics? Those are the questions I always ask is, if I'm going to go in and put data inside of a big data repository, do I need it to be in its pristine state, or can I tokenize it, or can I encrypt it? How much of that data is actually being used as part of the analytics? A good example would be, do I need the tax ID to be able to identify, did you pay your taxes, right? I mean, I don't need that. I just need to see, hey, you're in the red. You didn't pay your taxes. The analytics is more on the the values, not necessarily the lookup record or the sensitive data. It's when you need to use that piece of sensitive data potentially later. That's where you'll want to encrypt or decrypt it then. So I always recommend, if you're going to go put sensitive data in there and you're going to find a way to actually control it, if you need to be able to actually look at the data during the analytics or use pieces of that data during the analytics, it needs to be in the clear to do so. So techniques like either tokenization and encryption will need to actually detokenize it to look it up. This is why transparent encryption is a very good use case for when you don't know what you'll need. You don't know what's sensitive yet, or you don't know what needs to be, separated from each other. Transparent encryption is a very, very good technique, because what you do, at the minimum, you're making sure the infrastructure can't see your data. Only the business logic and the business applications that you're bringing to the platform can. That's a great technique. But if I need to get more granular,
that's what you
can do so.
Is this what you're using in the mixing bowl approach, when you have your three different encrypted sets of data combined? So they're not actually decrypted as far as the user is concerned while the analysis is going on, or not necessarily?
Right, yeah. So what's happening is, if you do that transparent encryption approach, for example, what was happening there in that big, the mixing bowl, use case is they had three distinct different data owners, three distinct different data sets, and three distinct different data controls. They were using encryption with separate keys and policies and so forth. And the policy would say, when I go to submit it into the big data platform, I want the data to be encrypted. Again, this will be another set of encryption keys with the unique session key or unique mixing bowl key just for this job or this analytics I'm going to run. And only that job has the ability to decrypt it. But I didn't need to go down to that field level or value level. I didn't want to do those individual elements because I need all those pieces to actually make the analysis. So having trillions of potential pieces of data in there, I can't have trillions of potential detokenizer encryption operations on a per field basis. This is why transparent encryption was the platform of choice for them. They actually did use transparent encryption as well as some application encryption because there were some fields that were so sensitive but were not part of the analytics that they needed to make sure it stayed with the data because there was value on the analysis side at the very end. So
does this help then in issues of identification of individuals via big data? When you're using, I don't know, medical conditions, and the combination of conditions and the geographic location might inadvertently identify an individual. Does that get covered through this approach?
Yeah, so the transparent encryption, the analytics could still potentially, find an individual just because they're able to run the analytics. Tokenization is a good technique for actually de-identifying or, they call it, you're giving it a surrogate value. So you might be able to de-identify some of the sensitive data, but you could still identify trends. For example, in this part of the country, I'm seeing a trend in a certain disease, or I'm seeing more heart disease in this particular city. You could find that information, but still not be able to see the data because the data is either tokenized or encrypted at the field level. When you do it at the repository level, you still get to see that since the job does, the analytics does. So you have to be good at the source. If your risk is identification of an individual, then I really highly recommend tokenization or app encryption for the pieces that might be very, very sensitive or regulated.
Okay. Now, another area, and it slightly gets touched by that, is the whole area of regulation. And there's different aspects of regulation. There's the whether you see any changes coming in relation to regulatory frameworks being more specific about how to control privileged users, and what you would like to see in that area. But also the other one is the cross-border regulation. But we'll cover the first the privileged user first.
Sure. Yeah, so I think if you look at, here in the States, for example, there was after the Edward Snowden event, there was this idea that was floating around for a while called the two-man rule, right? Have to have two people present to actually get a privilege level account to actually perform a function. It's a great idea, right? It doesn't solve the problem, though. At the end of the day, what they're talking about is I'm going to release access to a privileged user account to two individuals when they collaborate together. That's a great idea. It doesn't solve the underlying problem, which is there is a concept of a privileged user, and that process, that user account, has access to everything on the platform, whether it's a router, a switch, an operating system, a Linux server in the cloud. Doesn't matter. That super-level user is always going to be present. The regulation to how somebody gets it is a great control. The other part that I always recommend to folks, though, is I would like to see, the vendor community, particularly the platform providers, I would love for them to see mitigations to that particular control, or mitigations to that particular account. Here at Biometric, we've been in the business of actually solving that problem for 13 years. So we first started the company for was protecting super users, root in this case, from data. They can't see the information, but the Oracle database that needs to see it still can't, but root can't. I would love to see better regulations and pressure on the community to actually fix this underlying problem, which is there's a privileged user problem built in. This concept has been around for a long time. It's called ring zero. If you guys remember from your computer science 101 class, there's this concept of the kernel. All super user account types, whether it's a domain administrator, whether it's a local admin, whether it's root, they're using that ring zero level of privilege to do things like configuration management, patching, and so forth, but also the data comes with it. That's the challenge, and I think that's where a lot of folks focus on the individuals of a privileged user, not necessarily the account and the underlying rights it has. That's one thing I highly recommend to folks is when you start talking about leaving your data center, or you're going to big data, or you're going to cloud and somebody else's architecture, you need to rule that user out as quickly as possible, because that is the number one biggest risk to data, is the privileged user accounts that have access to that data. And guess what? The attackers know that. And guess what all the malware is written as? They're all trying to leverage that ring zero, right? They want to escalate privilege. What if I take away that escalated privilege? You could have all the escalation you want, but you still can't see the data. You can't steal what you can't see.
Now, the other area of cross-border regulation is that you're getting conflicting arguments being put forward. You've got the U.S. wanting to access Google data held in Ireland. You've got China saying that it wants backdoors. The U.K. potentially asking for backdoors. Russia and Germany saying they want all their data held within their territory. And actually, again, pressure to have backdoors into encryption, which I know it goes totally against everything an encryption company stands for. But how do you cope with dealing in territories where their regulations are in conflict with your home jurisdiction?
Sure, and that's where a lot of, especially our customers, our customers are very large enterprises traditionally, and they wrestle with the same problem, right? A good example would be a credit card processing company that has multiple data centers throughout Europe. They're trying to consolidate to a single data center in one country. The challenge was the German data governance laws really put a burden on them of how do I keep the data protected and only viewable by a German employee or a German citizen, of German citizens, even though the data center is going to be in Poland. How do I wrestle with that? And that's where we brought in a technology to help them do that. We encrypted the data inside of Poland and allowed that only the keys and the policies and the users are all in Germany. Germany. So they put an actual control in place so the data might live somewhere else, but it's unusable in that other location. It's only consumable by the people that have the key to consume it in Germany. So only German data can be seen by a German citizen. And
that's been accepted by Germany then, because I understood that they actually wanted the actual the data to reside in Germany.
I believe from the last contract that I had with them, they had, I think we're still going through the audit phase of that, but that's their strategy, is to actually keep the keys, policies, and operators of the data in Germany. The data center will still be out of the country.
Sounds like a news story. I'm going to have to follow up with you.
Yeah, absolutely.
That's really, really interesting.
It is interesting because, it all comes down to, is the data usable in the country where the data sits? No. You can't use it in Poland unless you're a German citizen coming in from Germany with the appropriate key to decrypt it. That was their strategy. So we'll see how it plays out. But that's a common way that people might want to approach the problem. Because to them, it's cost savings, right? They want to reduce the number of data centers, not increase. And that's a challenge.
Absolutely. Otherwise, you're losing all the benefits of cloud. Yeah.
Yeah, exactly. And that's where it gets to be a challenge. And there's these concepts of like localized clouds or localized data centers, which, if I'm a service provider, I don't want to have a data center in every country. And it's very expensive. Talent and, facilities and power all fluctuate and are different, country by country. It's challenging. So how do you find ways to address this problem? And encryption is going to give the ability to do that.
Okay, we're running out of time, so this is going to have to be the last question now. So I guess we'll go for a sort of summation type question. So what would you say are the biggest challenges to overcome when adopting cloud services and data approaches? What I mean is, the objections that you get, and how do you tackle? What are the biggest objections, and how do you tackle them?
Yeah, so I'd say, if I look at, I'll focus on cloud just because it's becoming very, very popular for a lot of organizations to embrace it. The biggest challenge is always data ownership, right? Who is responsible for the data's availability, the security of it, and potentially the recovery of it later on. So one thing I've seen, a lot of organizations do when they're going through that vendor selection process is going again to that checklist of who has access to my data, where's my data reside, do I have any controls of it? I mean, you have a lot more control over infrastructure as a service provider because you basically bring your own IT is what you're really doing. You're using their infrastructure, but you're bringing your own IT. Whereas in a software as a service provider, you need to have a longer conversation with the platform provider, the service provider, because that service provider doesn't really give you a way to interact with just your data. You're quite often in a multi-tenant environment. So this is where a lot of the challenge is can I find ways to actually protect data as it goes into a SaaS provider? Or can I find ways to partner with a SaaS provider to make sure I can control that data, whether again it's through encryption or what have you. So there are countless use cases we've seen where we've been a third party with a customer and a service provider to actually help them solve this problem. The customer wants to be able to control the keys, the service provider wants to get the revenue and service the customer, yet the architecture, there's a problem of data ownership there. We allow them to actually have the ability to do so through either transparent or application-type encryption where we work with the service provider. And then in the future, we're actually going down the path of having the ability for the consumer of that service to actually bring their own control, more to transparent encryption going up to the SaaS. That's a future thing that we're working on. But that's where I think more and more people are going towards is I need to have options. I need one for my infrastructure service. Maybe I've got a good partner with my software as a service that might be higher up in the, from a sophistication standpoint, and they want to partner with me to make sure my data is protected. Or it could be that third one where I need to find a way to bring my own control. That's the part that's challenging for a lot of organizations right now. How do I go to a tomorrow's service provider that just came out of stealth mode? How do I make sure that my data that goes in there is protected?
So it's all down to control. And I guess we kind of knew that was the issue, but I think we're saying that we've got it more resolved. That really will have to be it for this session. We've run out of time. Our thanks to Sol Cates for sharing his insight and expertise today, and thanks to all of you for tuning in. This webcast will be available on demand beginning tomorrow on the SC Magazine UK website, scmagazineuk.com, under the Events tab. Thank you very much.